I'm going to show you how you could fly across the galaxy and literally outlive every single person you know. I'm not talking about a few days, I'm talking centuries. What if you came back to Earth after what felt like 5 years, only to find out that hundreds of years had passed and everyone was gone? This isn't a crazy movie plot. This is a real, mind-blowing secret hidden in Albert Einstein's equations. And it proves that the clock on your wall is basically a complete illusion. Today, we are breaking down one of the most famous challenges in all of physics, the twin paradox. And we're going to uncover the insane and honestly terrifying reality of what it means to age at the speed of light. To get this, you need to hear this story. Imagine two identical twins, Stella and Tara. They are the exact same age, down to the last second. Tara stays on Earth, living a normal life. But Stella is an astronaut. She gets in a crazy futuristic spaceship and blasts off on a mission to a star system light years away. Her ship is fast, like unbelievably fast. We're talking almost the speed of light. She flies to the star, turns around, and comes back. For her, the trip felt like maybe 5 years. But when she gets off the ship, the world is completely different. Her twin sister, Tara, is an old woman, or she's been dead for decades. It's possible centuries have passed on Earth, all while Stella, the space twin, has barely aged. This is the twin paradox. But this is where it gets insane. According to Einstein, all motion is relative. So from Stella's point of view in her spaceship, she was standing still, and the Earth zoomed away from her. So shouldn't Tara be the one who aged less? How can they both see the other person moving and aging slower? It feels like it makes no sense, but it's not a contradiction. When they meet, there is only one answer. Stella, the traveler, is younger. The universe knows who's who. The secret is all about destroying the symmetry that seems to cause the problem. To solve this insane mystery, you first have to understand time dilation. Einstein's 1905 theory of special relativity completely changed how we see everything. He proved that space and time are woven together into one thing, space-time. And the craziest part is that time moves differently for everyone, depending on how fast you're going. The faster you move through space, the slower you move through time compared to someone standing still. Think of it like this. Everything is moving through space-time. If you're just sitting on Earth, you're mostly moving through time. But when you start moving like crazy, you have to use up some of that motion. It's like you have a space-time speed budget. The more you spend flying through space, the less you have for traveling through time. And this isn't just a feeling, it's real. Your cells, atoms, clocks, everything physically slows down. At normal speeds, like in a car, the effect is so small you'd never notice it. But once you get close to the speed of light, the universe's ultimate speed limit, the effect is massive. Time for you could slow to a complete crawl compared to Earth. So back to our twins. As Stella rockets away, her body clock literally starts ticking slower than Tara's. But here's the confusing part. On her way out, if they could look at each other, they would both see the other's clock ticking slower. This is what special relativity says, and it's where everyone gets lost. If they both think the other is younger, who's actually right? This perfect balance only works as long as Stella is at a constant speed. To get home, she has to do something Tara never does. She has to change her journey. The solution to the paradox, the secret that makes the space twin younger, is acceleration. The twins' experiences are not the same. Tara, on Earth, is in a single, stable, inertial reference frame. She's just cruising with the planet, not feeling any insane G-forces. Stella, on the other hand, has a completely wild ride. To get to near light speed, she has to accelerate like crazy. Then, to come home, she has to slam on the brakes, turn the ship, and accelerate again. And finally, she has to decelerate to land on Earth. Every time she accelerates, decelerates, or turns, she is breaking out of her inertial frame. It's this physical change in her motion that shatters the symmetry. This change is everything. Special relativity is for constant speed, but general relativity tells us that acceleration feels exactly the same as gravity. And what does gravity do? Gravity bends time. A clock in strong gravity ticks slower. So by accelerating, Stella is creating her own insane gravity-like effects, which completely changes time for her compared to her sister. So, while both twins see the other aging slowly during the long cruise, it's the turnaround that creates a massive, one-sided time jump. In that moment, Stella's now jumps across decades or even centuries of Earth time. When they finally meet, Their clocks don't match, and there's no confusion. The twin who felt the G-forces, Stella, is the one who lived through less time. The paradox is solved. Not because the physics is wrong, but because the twins had completely different journeys. One took a much more violent path, and it made all the difference. Now, this might all sound like a cool story, but time dilation isn't just a theory. It's a proven fact. We don't have spaceships that can hit near light speed, but we have things that move incredibly fast, and clocks that are so precise we can see the effect. The best real-world proof is the International Space Station. Astronauts on the ISS are flying at 28,000 kilometers per hour. At that speed, time for them ticks just a tiny bit slower. After 6 months in space, an astronaut is about 0.005 seconds younger than everyone on Earth. It's a super small number, but it's real, and it proves Einstein was right. And for a story that is almost identical to our thought experiment, you have NASA's twin study. Astronaut Scott Kelly spent a year on the ISS, while his identical twin brother Mark stayed on Earth. When Scott came back, he was literally younger than his twin by a few milliseconds. He didn't come back to the future, but the principle was proven. Scott Kelly actually time-traveled into the future, even if it was just by a fraction of a second. This effect is also why your GPS even works. GPS satellites have super accurate atomic clocks, and they are moving incredibly fast. If the engineers didn't correct for time dilation every single day, the tiny errors would add up, and your GPS would be off by several kilometers. The fact that your phone can find a coffee shop is proof that Einstein was a genius. The time-bending effects on the ISS are tiny because the station is barely moving compared to the speed of light. But Einstein's equations show us what happens when you really hit the gas. This is where the secret to aging slower becomes a key to exploring the entire universe. Let's go back to Stella and use real numbers. Say she travels to Alpha Centauri, 4 light-years away. If her ship could fly at 99.5% the speed of light, the time jump would be huge. For Terra on Earth, the round trip would take about 8 years. But for Stella, time would pass at only 10% the normal rate. The entire trip would feel like it took less than a year. She'd come home a few months older, while everyone else would be almost a decade older. Now let's get even crazier. What if we wanted to cross the entire Milky Way galaxy, 100,000 light-years? It seems impossible. But if you could travel at 99.9999% the speed of light, an astronaut could make that round trip in what feels like just a few decades. But when they got back to Earth, 200,000 years would have passed. They would have jumped into an unrecognizable future. This is the ultimate consequence of Einstein's secret. Speed isn't just about travel. Speed is time travel. If you go fast enough, you can literally step out of the river of time, let it rush past you, and then step back in, far into the future. It's a one-way ticket to see what's next, a future where you've left everything behind. So, Einstein's secret to aging slower isn't just a weird physics puzzle. It's a fundamental rule of the universe. Time is not a steady clock. It's a flexible, stretchy dimension that's linked to space and motion. The faster you fly, the more you stretch one of your moments to cover years, or even thousands of years, for everyone else. We saw how the twin paradox, which seems impossible, is solved by one thing: acceleration. We've seen this proven by astronauts and the GPS in your phone. And we've explored the most mind-blowing idea of all, that any trip to the stars is also a leap into the distant future. It turns out the universe has a built-in fast-forward button. It's a one-way ticket, and the price is leaving your entire world behind forever. It's an insane secret that proves the here and now is different for everyone, and that every journey into space is also a journey through time itself. And that's what makes physics so awesome. If you agree and you want to go on more insane adventures to the edge of science, smash that subscribe button and ring the notification bell.